Over the course of this week, we are going to learn how to write proofs for geometry. So today and tomorrow, we're going to work specifically on segments. Thursday, Friday, we're going to work specifically on angles. Okay. And then basically all of the chapters from here until winter break, we will be writing proofs of some kind. Okay. But good news, second semester, we don't. Okay. So let's first talk about all the things that we just talked about. So all of these properties of equality, they can be used anytime there's an equal sign. Okay. If there's an equal sign, we can use these properties. Okay. So even if we're talking about segments, okay, as long as there's an equal sign, we can use these properties. Okay, they still exist. Now, if we have a congruence sign, we have three properties that we can use for congruence. Okay, remember congruent is that little squiggly. Okay, when we're talking about segments, an equal sign means we're referring to the measure, but a congruent sign means we're talking about the segment itself. So the reflexive property. So what is the I can't talk. What does the reflexive property of equality look like? Give me an example. X equals X, okay? So if we're talking about segments and we have reflexive property of congruence, then for segment AB, we would write AB is congruent to AB. Okay. Symmetric property. How many segments would we need to be talking about for the symmetric property? 2. So the symmetric property, if we know that AB is congruent to CD, then what would our symmetric property tell us? CD is congruent to AB. Very good. Okay. And then we also have the transitive property of congruence. Okay. This is going to involve how many segments? 3. If AB is congruent to CD and CD is congruent to EF, then by the transitive property, AB is congruent to EF. Okay. So we can use these 3 properties of congruence within our proof. Okay. Okay. Now, as you're writing that down, when we started talking about proofs last week, we said that we could use properties for reasons. We said we could use definitions for reasons. We can use postulates, we can use theorems. Now, we really didn't have to use postulates, theorems, or definitions last week because we were just working with algebra. Okay. Well, now that we're getting into the geometry proofs, the geometric proofs, however you want to say it, we are going to need to pull from our toolbox of not only properties, but definitions, theorems, and postulates. Okay. So let's talk about some definitions that we already know, but how are we going to see them being used maybe in a proof? Okay. So the definition of congruence. Okay. This is going to be important if we need to work with segments in a specific way. So we know that segments are congruent if and only if they have the same measure. What does that mean? That means if I have two segments that are congruent, then I know that their measures are the same. Okay, here I'm talking about the segments being congruent. Here I'm saying their measures, like their actual like numeric measurements, are the same. Okay, and since this is an if and only if statement, we can write this the other way also. So there may be some times where you need to go from congruence to equals or equals to congruence, okay? That would be this right here. We're using the definition of congruence to get from one to the other. Okay. Now, in a segment, we're gonna have some midpoints. Okay, what does a midpoint do?
It's like cuts down the middle of two.
Oh, two congruent pieces.
Two equal.
We have two equal congruent pieces. Okay, so if M is the midpoint of AB, then we know that AM is congruent to MB. If M is in the middle, it is breaking it up into two congruent pieces. Okay. I'm also going to make a note here. You could use this either way, whichever one is going to be to your advantage. You can use the congruent piece, or you can use that they're equal, the two pieces. Okay, kind of depends on which piece is going to be more helpful to you. Okay. We're starting with segments because we don't have as many properties with segments as we do angles. Last thing we're going to talk about before we actually like look at doing a proof is the segment addition postulate. Okay, I have three collinear points. Segment addition postulate. So let me just don't write this down. Let me just remind you. What did you do if this was 5 and this was 2 and I said, hey, what's the measure of AC? You added them together, right? Okay, so in terms of this general segment that we don't know the measure of, we know that the piece that is AB plus the piece that is BC is going to equal the entire segment AC. Little piece plus little piece equals big piece. Okay, if you would like me to say it like that.
Is it 6 and 7? Why is funded?
I'm just saying they're smaller than the whole thing. Okay, so green piece plus orange piece equals the whole yellow piece. How does that sound? Okay. All right, so here we go. We're going to start writing some proofs. When we are writing proofs, our reasons are going to be properties, definitions, or postulates. So go ahead and turn to the next page, page 12. We're going to go through some proofs where the statements are already done for us, so you can kind of see what that looks like. What do we always start with? What's our first set. We always start with the given. Okay, so our given information, E is the midpoint of DF. Okay, E is the midpoint of DF. Okay, well then we're gonna think, okay, what do we know if we have a midpoint? We know we have two equal pieces. So I'm just gonna write this on our diagram. Oh, and look at what our next step is. Because we know that E is the midpoint, we can write DE equals EF. What gives us the right to write that?
We know that E is midpoint.
Okay, so what would we write here? We wouldn't write, we know that E is the midpoint. We would write something about the midpoint. Definition of midpoints. Okay. Now, we are trying to get to 2DE equals DF. So this whole thing is DF. And we're trying to prove that 2 of the DEs equals the entire DF. Okay. Does that seem like something that is legitimate? Like, does it seem like something we can use logic and get to that conclusion? Okay. So I'm eventually going to need 2DE, right? Okay, so look at this next step. In step 3, what happened to both sides? We added a DE to both sides. Why do we do that? Or what gives us the, okay. So that's kind of from what we talked about like in the past couple of days. That's one of like more of our algebra things, Nora. It's up at the very top. But instead of using algebra, we're using segments, which kind of seems like that, right? Now, because we have DE plus DE, we can write 2DE. Okay, on those, I just want you to write simplify. If you combine like terms of any kind, I want you to use the term simplify for that. Okay. Okay, now in the step 5, we have DE plus EF equals DF. Small piece plus small piece equals whole piece. What do we call that? That is our segment addition postulate. There's a pretty good chance you're going to have to use the segment addition postulate in a majority of these proofs. Okay. All right. Well, now look at what we have. We have 2DE equals DE plus EF. Then we have DE plus EF equals DF. Oh, this is so great. Yes, look at that. Do you see how these my orange highlights match? Okay. Yellow equals orange and orange equals green. So we can conclude with the transitive property that yellow equals the green. And now we have gotten them. I'm not answering that question right now.
On the board, it says what you need to study geometry every day.
Do you know the
It'll
answer to that one?
shape your character.
I like that, but that's not my pun.
There's 2 extra.
Okay. Before we look at number 2, do you have a question on any of the reasons for any of the steps? It's on the board. Alexa was looking for the joke. It's there's a math joke of the week every week outside of my room. Friday, I put up the answer. Okay, let's look at number 2. Okay, so our goal is to take this picture and prove that L is the midpoint. Okay, so right now we know that KL is congruent to LN and LM is congruent to LN. Okay, so that is our given. Okay, so I'm gonna put some markings on my picture just to help me. We know that KL and LN are congruent. Okay. Okay, so what happened from step 1 to step 2? You agree with Clark? We went from congruent to equals with the exact same segments. So this is definition of, and you know what? I'm going to be a little bit lazy. You put the symbol and then it's a lot less to write. What?
Well, how did you just put like this thing?
Then that's not congruent. Okay, if you only have the squiggle, then that's approximately. Okay, then what happens from step 2 to step 3? I have KL equals LN, and I have LM. It's not the transitive property. It's not subtraction because so it's almost, honestly, if you put the transitive property, I'm probably not going to count you wrong. So technically, this is the substitution property. Because I'm taking the purple, LN, and I'm replacing it with what it equals, LM. Technically, it's not the transitive property because the purples aren't right next to each other in our 2 statements. Do you see what I'm saying? Yeah. Okay. But I'm probably not going to throw a big fit about it if you were to put transitive property because it almost is. Okay, that's not the hill I'm going to die on. Okay, well now if we know that KL is equal to LM, then we can assume that L is the midpoint. What would the reasoning be? Yeah, definition of midpoint. Okay, we can use it either way. We have the midpoint, we know they're equal, or we know they're equal, so it's the midpoint. Okay, we can use it either way. Hi. Oh, okay. Thank you. You have shoes in the front of this. All right, party people. Now we get to do one on our own. Together. Hey, guess what? We know what to put first. All right, so PQ is congruent to TQ. And UQ is congruent to QS because that's the given. And you know what else would be a good idea? I think it would be a good idea to mark our diagram. PQ is congruent to TQ. And UQ is congruent to QS. Okay, our very last step is going to be PS is congruent to TU. Okay, that's where we need to end. We don't know the reason yet, but we know that's where we need to end. What are we working with here? At the very end of this, we need this entire segment to be congruent to this entire segment. Okay, so we know some information about like the little pieces, right? And we're eventually going to prove the big pieces are equal. So what do you think that somewhere in our proof we're going to have to use? I know information about the little pieces, and I want to prove the big pieces are equal. Segment addition postulate is something we're going to have to use. Okay, now does the segment addition postulate have congruent signs? No, it has equal signs. So the first thing we need to do is say, all right, PQ equals TQ and UQ equals QS because the definition of congruence. Okay. Okay, now Nora, you said the segment addition postulate would be good, right? So let's do the segment addition postulate. We know that PQ plus QS equals PS, and we know that TQ plus QU equals TU. Okay, this is where things get a little crazy. Okay. I want to prove two pieces are equal, okay? So right now, if we look at this guy right here, PQ plus QS, I'm gonna have to do something with that statement. What do we know? What is the same as PQ? Oh, okay. So could we write TQ plus QS equals PS? Could I take PQ and change it to TQ?
Yeah.
Why can we do that? Okay, so we call that what? When I replace something? Yep. Okay, I took PQ and I replaced it with TQ. Okay. Oh, guys, look at this other one. This other one is TQ plus QU. So I like that this is TQ. It's getting weird saying TQ. But what is QU the same as? No way. So we took QU and it's the same as QS. Oh, God. Do you see something? You don't? What does it say? Everybody read it with me. Read this one.
So PS equals TU.
That's so great. Okay, how do we know this? Right here. How did you know PS and TU were equal? We can, you know what? Let's say the transitive property. I think that's right. Substitution would also be fine. I'll be flexible on this one. Okay, now how can we go to PS equals TU to PS is congruent to TU? Yes, I would not suggest using a homework class on this one.
I don't get a homework.
Okay, your homework is going to be
Nah, there's no way we have a quiz.
page 12 and 13. Now look at page 12. Look at page 12. Are the proofs written out for you except the reasons? Yeah, you just got to figure out the reasons. Oh, it's 13 and 14, sorry. Okay, so page 13, the proofs are written for you except the reasons. Look at page 14. Page 14, you got to come up with some statements, some reasons. You only have one proof to do start to finish by yourself. Okay, now, this is not like algebra where there's like one way. Okay, your proof might look a little bit different than your neighbors, but as long as it's logically sound, it's fine. Okay, is this going to be like, oh, I got it, it's super easy right away?
No.
This is going to make you think a little bit, but you cannot just like turn away from the challenge. Okay, you're gonna be uncomfortable, but being uncomfortable is how we learn. Clark. You know what? We have a quiz on Wednesday, so you let that be up to you.
Not really.